This video shows how to set up a thorough interconnect or structural test with pin-level diagnostic messages for printed circuit boards using Flynn Systems circuit trace and IEEE 1149 boundary scan technology. This is the first in a series of videos that explain how to create and run interconnect tests and script programs in circuit trace. We're going to use a Xilinx evaluation board as the target printed circuit board for this demo. And the board has 4 boundary scan or JTAG devices on it in a single chain. It has DDR memory, SRAM, and a number of LEDs, some of which we're going to use to demonstrate script programming. The board connects to an on-tap JTAG USB controller. This controller has 2 JTAG ports, and it is connected through a ribbon cable to the test access port on the printed circuit board. Pictorially, the JTAG chain looks like this. Here's the JTAG port with the test access port signals, test clock, test mode select, TRST, TDI, test data in, and test data out. These are standard boundary scan or JTAG signals, and the test data in connects to the first device in the JTAG chain, and then it connects serially through some more devices to the last device in the chain, from which test data out is connected back to the TDO port on the tap. The TCK and TMS pins are common to all of the devices in the chain, and they control the tap state machines in each of the devices. In addition, we have some non-JTAG components on the board, such as resistor packs, and you could have buffers, you could have transceivers, any number of types of devices that we want to make transparent for the purpose of driving boundary scan signals between the boundary scan pins. So we're going to show how to do this. We'll be going through some non-JTAG components and connecting to more boundary scan pins. When starting a new project, you go to the System menu, select New Project, and what we want to do is go to our project folder, which needs to have the boundary scan description level files, BSDL files that describe the boundary scan implementation in each boundary scan device. And so we will go to a folder that has that. So we will select this folder, CTNet Starter, and it will list the BSDL files in the folder. Next, we want to pick out a net list. Now the net list is very important, a CAD net list, because it lists all of the components, shows all of the components on the board, boundary scan and non-boundary scan. And in addition, it shows the connections, the pin connections between all of the components. So we're going to select that. And at this point, we will simply click OK. And that will bring us to this situation. Now the user interface at this point shows that we're in the JTAG setup area. And the reason for this is that we need to define the JTAG chain. We need to tell circuit trace just how the boundary scan devices are set up in what order. So we're going to do that. That's why the BSDL files are shown here. And they need to be matched correctly with each of the reference designator components on the board. In addition, we've read the net list, and A circuit list of all of the components is shown. Unfortunately, just the CAD references are shown and not the actual device component names, which are very helpful. And that is usually the case for most net lists. In addition to the list of logic components, we can sort this by net. And here we have it sorted by net. And in addition, it's sorted by the highest pin count nets. That's important because ground and power related nets normally have the most pins, and they're shown at the top. And we want to identify these nets as such so that we're not, for example, trying to drive a ground net high. And we also want to be able to test that a ground net is low and a power net is high. So at this point, we could go ahead and define these nets. For example, that's a ground net. We see some power-related nets. Do that. Ground-related net. Some more power-related nets. Let's say a ground net. Okay, so that needs to be done. Another thing, another panel that we could look at is the controllers. And this panel will show all of the controllers that are attached. In this case, there's just one dual port controller, and it shows some of the options and items on the controller. For example, the TCK, the test clock rate, is shown at 9 megahertz, which is the default. It goes up to 30 megahertz. And in addition, in the solutions list, there's a file viewer. And for those who are not familiar with BSDL files, I think it would be useful to just show what a BSDL file is. This BSDL file represents a CPLD, and the -- are comments. There is going to be a list, a ports list, so all of the ports on the device, the pins, are defined here, the port names, and the type of port that it is. In, out is bidirectional. The tap pins, test clock, test data in, test data out, TMS, are shown here. There is no TRST, test reset pin. These pins are an input, dedicated input. TDO is a dedicated output. TMS, dedicated input. Some power-related linkage bits, which we won't get into. The next thing is a pin map string, and this maps port names to actual package pin designators, which can be numeric or alphanumeric for, say, a ball grid array. Go through this list. Then we have a list of the tap pins, a formal list. Tap scan in is called TDI, tap scan out TDO, and so forth. The clock rate is specified here, and let's see, it's 10 megahertz. We now have a list of opcodes. These are the instruction codes that are scanned in that control a test access port operation. For example, you can bypass the boundary register. Xtest controls the boundary register. There's an ID code register pattern that we can scan out. This is very useful for auto-detecting JTAG chains. And in a tap test, here is the boundary register declaration. Now, the pins, the boundary scan pins all around the device, any boundary scan device, are going to be controlled by boundary register cells. And this is a long serial chain of cells around a device, and it's controlled by the tap. Test data in, test data out. Data gets scanned through this boundary register. For example, this pin at this port, here's cell 428, this is an input at this port name. This is an output 3, tri-statable, at this port name. And this control cell, 426, is used by this output cell to tri-state or not tri-state the output 3. So 3 pins here, 3 cells, are used to control 1 port. And then we continue with the list. It goes on to cover all of the boundary register cells as well as pins in the device. So now that we have read in a netlist, and if you don't have a netlist, circuit trace can work with just the JTAG devices, but it's not going to be as thorough because you're not going to be able to see devices that boundary scan signals are transmitted through and receive. So we have the netlist, we have the BSDL files listed here in our setup area. The next thing that we can do is use auto detect to detect the chain. So we'll do that. And it has done so. It has found 4 devices, and it lists the devices in order of the BSDL files that it finds based on the ID codes that it scans out. So we know we have 4 devices, and we know the devices are represented by these BSDL files. Now we could go ahead and simply add these auto-detected devices to the JTAG logics and define the chain that way, which is the easy way to do. But let's say you don't have a board connected for whatever reason. The other way to do this is to go into the circuit, into the logics list, and select the devices that you know, say, are boundary scan devices. And in this case, we know it's these devices. And what we'll do is simply place these in this list. So we also know, or I know, that the JTAG chain order starts with test data in U4. So we'll just drag these to the right location. All right, and the proper BSDL files are assigned because we did this auto detect. But if they weren't, you would simply drag the BSDL file name over the device reference designator, and that would take care of that. So you would have a JTAG chain defined from test data in to test data out and the proper BSDL files assigned. So once that's done, you can click OK, and Circuit Trace will build a model, which it has done. And so at this point, you can select a device. Oh, the JTAG chain will be shown, I should mention, at the top. It's also shown in the list of all components, but it's shown at the top for convenience. So you can have ready access to it and set whatever options you might want to do, which there are quite a few. And we'll get into some of those later. But at this point, you're ready. You could scan all of the pins, or you could pick one. Started is to go to the controllers panel and select Save Adapter File. This will make sure that the chain that we have, which is chain A, JTAG chain A, is matched up to the controller channel A on the JTAG controller. Then once we've done that, we can then go select our component on our circuit, select a pin, and we can wiggle a pin high, we can wiggle a pin low. You can see the value here as we wiggle the pin on the board. Or we can run all of the pins. In the next video, we will examine the procedure to trace connections throughout a board and build an interconnect test.